Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The stability of cyclohexane conformations depends on ring strain, torsional strain, and steric interactions. The chair conformation is the most stable conformation for cyclohexane and its derivatives because it minimizes both angle strain and torsional strain. When substituents are present on a chair conformation, equatorial positions are preferred over axial positions to minimize 1,3 diaxial interactions. Moving on to the next step. Identify each structure. Option A shows a boat or twist boat conformation of cyclohexane or substituted cyclohexane. Boat twist boat conformations are higher in energy than chair conformations due to torsional strain and flagpole interactions. Option B shows a chair conformation of methylcyclohexane with the methyl group in the axial position. Axial methyl groups experience 1,3 diaxial interactions, making this less stable. Option C shows a chair conformation of methylcyclohexane with the methyl group in the equatorial position. Equatorial methyl reduces 1,3 diaxial strain compared to axial, but there is still a substituent present. Option D shows a plain chair conformation of cyclohexane with no substituents. This has no 1,3 diaxial interactions and no steric strain from substituents. Moving on to the next step. Compare stabilities. A plain unsubstituted cyclohexane chair, D, has no axial substituents and hence no 1,3 diaxial strain, making it the most strain-free. Option C is more stable than B due to equatorial versus axial preference, but still has a methyl substituent introducing some steric consideration. Option A is a non-chair conformation with higher torsional strain. And for the final step, rank the options. The order of stability: D. Plain chair, C. Equatorial methyl chair, B. Axial methyl chair, A. Boat twist boat. Why other options fail? A. Fails because boat twist boat conformations have significant torsional and steric strain. B. Fails because the axial methyl group creates 1,3 diaxial interactions. C. Fails because even with equatorial methyl, there is still more strain than an unsubstituted chair. Therefore, the correct answer is D. Therefore, the correct answer is option D.